Algebra 1, this is day 3. We talked about this one yesterday, and we talked about that it's always the opposite of H. What you see in there tells you the direction it goes. So the first one there is translated to right, for left, to left. And it's based off of this right here, right? What's the H? And H, guys, is with X, so you're moving in the X direction, which is horizontally. So, we should graph one of those. Which one do you guys want to graph? Let's graph B. It's a bigger change. Okay, so this is what I suggest. I suggest you, again, have a problem with a child or a part of a graph. You find its parent. So, what's the parent of y equals 2 to the x plus 4? Take away all moving parts. There's no a value here, right? And there's an h value. So, h is our moving value. If I take that h, or that negative 4 in this case, away, I think everybody should see that it's just y equals 2 to the x. Because I'm taking the h value out. From yesterday, you guys would say, hey, that's growth. Yeah? We would also say that, hey, y equals 0, 0, comma 1, and we need an extra point, and the extra point will be what? 1, comma 2. Now, yesterday, we just did the family thing. We brought in a. Well, a is 1. That means I multiply that equation by 1. Does anything change? Multiplying something by 1, does it change? No. It doesn't change. So therefore, there would be no family associated to this one. We're going to go right to the child part. Okay? So, when I go to build my bridge on this one, I'm going to, because I said this is the first part of the child, I'm actually skipping right over the family. Because remember we talked about yesterday that if there is no change, do I have to state there's no change? No. I don't want to state that. I'm only going to state the things that change. Now, if there will happen to be an a value, you have to do that first because that's multiplication versus this is addition or subtraction. So the child graph that we're going to talk about is 2 to the x plus 4. What's going on with this graph again? Where is it going? What were the words to describe how to get there? It's translated 4 left. Now wait a minute. If it's going 4 to the left, that means every single point, everything about that graph, which is this stuff, is all going to be picked up and moved to the left 4 places. Does that affect any y's? No, it only affects your x's. So guess what? If I took a horizontal line, just for example, y equals 0 is a horizontal line. Pick it up, move it 4 spaces to the left. Is it still y equals 0? Yeah. It's the same line. Doesn't change. If I take the point 0, 1 and I move it backwards, remember, this is the y's, no change. You don't have to state that. But then I'll also say that the x is subtract 4. So 0 gets to be subtracted, right? I start off at 0. That's my x. I have to subtract 4. I end up at negative 4. 1 is a y value. Am I changing my y's again? No. Still stays 1. And 1 comma 2 becomes what? Negative 3, 2. Is everybody able to get those points? That's what you graph. You're done. So this is really not too bad, is it? 1, 2, 3, 4. 1, 2, 3. So we got our dotted line at y equals 0 still. Not really part of the graph. Hold on. Negative 4, 1. And negative 3, 2. So guess what this graph has to do? Goes like this. And you're done. That's your graph. The next part is the vertical translation. Again, we have the order differently today. So this one I would call the second part of the child. And the second part of the child, this is the up and down movement. This brings in a k value. So what does it look like individually? It looks like this. Y equals b to the x and, plus k. So the thing I like to equate this to, for those who have a job, okay, you work some hours this week. The amount of hours you work will affect how much money you get, right? More hours, more pay, usually the way it goes. Once you get your paycheck, it's done for the week, right? You've got it. But what happens when mom and dad, here's a $20 bill. Which way did your money just go? Up. Did it affect how many hours you worked? No. It's like a bonus. What if at the end of the week said, hey, you remember that bedroom window you broke? You owe me $20. Now your money just went down. So this vertical translation is what happens at the end. It's an afterthought type thing. So that if you think of it as money, if everybody in the room got $5, everybody's at a different place in the beginning, right? But everybody's money just went up. So guess what? If you have a graph and you add something to it, the whole entire point, all the points and all of the graph will just go up. If you take away something, the whole thing just falls or goes down. It doesn't shrink it or stretch it. It's just like left and right movement. But guess what, guys? This one is really nice because it's the exact thing that you see. So if k is greater than 0, so k is positive, the graph goes up. When k is negative, the graph goes down. Okay? So, individually, A, you would say what? I want to say, it's translated, what? Not all at once. It's translated, we're doing A. There's a 3. So it's 3 up. It's at the end. It's at the end, so this goes either go up or goes down. Part B says it's translated one down. C, 1/2 up. It's as easy as that, guys. So we'll go back to Desmos and demonstrate that. Okay, let's graph one of these now. Which one?
First one.
First one. Okay, easy enough. Again, we're doing this first one. We have some movement going on. So automatically, I'm going to get rid of the movement, revert back to the parent. What is the parent of these? Y equals 2 to the x. We're going to say, hey, we just done this so many times. This is growth. It's y equals 0 because that's our asymptote. All parents have those. All parents have a y-intercept at 0, 1. And since it's growth, I'm going to put 1 in. When I put 1 in, I get 2 to the first power, which is 2. We have not changed that. That's going to happen every single time. If it's decay, I'm going to put a negative 1 in. Yeah? The same thing's going to happen now. Is there an A value? Is there anything in front of that power? So that means A is equal to 1. Do I need to state anything? No. Okay. So now we have movement to a child part. And that child part happens to be 2 to the x, and then plus 3. Yeah? So, what's the words on the bridges here? Translated? 3 up. We already talked about all of that. So what's going to happen to the parent graph? It's just going to go up 3. That is in the which direction? X's or Y's? The Y's. That means our X's will stay the same. So, when I go here, instead of saying Y equals 0, I need to add 3, right? Because, so X's are no change. And Y's add 3. So, it's not Y equals 0, it's Y equal 3. It's not 0, 1. It's 0, 4. It's not 1, 2. It's 1, comma 5. Can you graph those 3 things? Yeah. You've got a graph. So, Y equals 3. Oh, look at that. Our asymptote is above the x-axis. It's the first time. We have 0, 4 and 1, 5. And you have a graph. It's a wonderful thing. Is it a process? Yes. Why do we do this? Is that way you can look at an equation and you're going to be able to break it down into its individual parts and say, I know what this graph is supposed to look like, aka a parent. Is that now we know that there's going to be a vertical stretch or shrink, and there's going to be translated left, right, up, or down. It's moved. Kids have moving parts. Kids are all over the place, right? They're away from their parents. So you go back to the parent, you go to the family, which is an adjustment of the parent, and then you move it left, right, up, or down. Now, this is what it all comes down to. This is where we have to put the A, H, and K all together. And this is what I was talking about the other day. I was saying, hey, when you were to look at children, they kind of look like their parents and they kind of look like their family, right? It's because they're a mix of all of it. So this equation of y equals a times b to the x minus h plus k is what I actually will call the child. And to get to the child, you go through the process that I have laid out. I've actually done a modification every time we've graphed one. But you will have 3 columns most of the time. You will state the parent, which we've done now about 6 times. You will probably more than likely have a family aspect of it, which is that a value. So the family brings back a. A, multiplication, that comes first before the adding and subtracting of h and k. So, you go from parent, the family, the child. This is not perfect because there are no arches in here. These words of vertical, stretch, or shrink would be on the bridges, translated h units left, right. Obviously, you shorten these up, right? So it's a vertical stretch of 3, or it's a vertical shrink of 1/3. It's reflected about the x-axis, or I don't say it at all, right? I'm not going to say something that doesn't happen. Then, from the family to the child, I'm going to say, hey, it's translated h units to the left. So 3 units to the left. It's translated 2 units up. Or, if one of those is not there, I don't say it. If both of them are not there, I stop at the family. And the cool thing is, guys, you're going to have y equals 0. You're going to have 0, 1. And you have your extra point, right? Well, guess what? There's information here, and that information says you're still going to have y equals a point and a point, but it's going to be affected by whatever you said is the bridge, which is the a value. You're going to multiply things by a. What are you going to multiply? You're going to multiply y by a. Whatever a is. If a is 2, you multiply the y's by 2. If a is 1/4, you multiply the y values by 1/4. It makes it taller, it makes it shorter, right? If a is a -5, you multiply the y's by -5. The x's are not changed. We've talked about that as an individual piece. But then you move on to the child, which again still has y equals something, a point, and a point, right? Every single one of these has that happening. If you're going to go translated left, you subtract from the x's. If you're translated right, you're adding to the x's. So therefore, you're going to add, subtract h to the x's, or you're going to add or subtract k to the y's. You got to get that? It's exactly what we did individually, but guess what? That all three of those pieces are going to be in the same problem. You build from one. You built the parent. You found the parent. From there, you use the parent's information to get to the family. And once you get to the family, you springboard off of that to get to the child, and then you just graph the child. I could care less what the others look like. It's only three things: an asymptote, a point, and a point. And we've done that now about 6 or 7 times. So I want to graph this, but before we graph it, I want you to list what is happening. Because if you can list and tell me what's happening, the rest of it should follow. Now, this one, I'm not telling you what the parent is, like our other problems. You need to recognize that this does have a parent. You don't have to state it for the describing part, but what is the parent of this function? Y equals 3 to the x. Not 3x, but 3 to the x. 3 to the x power. Okay, if I started there and I ended up with y equals 2 times 3 to the x plus 5 minus 1. Tell me some things that are going on. What's the 2 doing out front? What value is that? What letter? That's an A value. A values tell us what? A is for, it's a family, but it should be the stretch or shrink. It's a 2. Is this a stretch or shrink? So it's a vertical stretch of 2. Would you guys agree with that? Okay, now we move on to the next one. It says it's x plus 5. What value is that? That's an h value. So we know it's 5. That means I'm translating here. It's translated 5 which way? To the left. It's always the opposite of what you see. And the minus 1, we would say, is translated what? 1 down. Does everybody understand where those all came from? Here's the thing. We have to do all of those to make that graph work. Do the same thing here. Oh, wait, let's back up. Let's back. Is this a growth or decay graph? growth, because the parent is, the base of 3 is bigger than 1, so therefore this is growth. Okay? When I get to this one, what's the base? It's 1/3. And 1/3 is less than 1, so therefore this one is actually decay. So when you get to your parent, you need to state that. Okay. Let's list what's going on with this one. What's going on? Vertical shrink or stretch? It's a vertical stretch of 3. Why is it a vertical stretch of 3? Because -3 is our number, it's our A value, but 3 itself is bigger than 1. What does the negative do? Now we have a negative. That is going to do what to the graph? Turn the direction. Other words for that? Reflected about x-axis. It's reflected about the x-axis. That means instead of opening up, it's going to open down. Next, any h value. It's a 2, translated to where? Still left because it's the opposite. And we're going to say it's translated 1. Everybody's got $1. What's going on? Their money just went up. Okay, guys, this is your homework. In the words, I want you to describe how to obtain each of these graphs from its parents. So there are 4 of them. Have a great day.